Number 37, state the property illustrated by each statement. Um, on, let's see, you guys remember what page those were on? I think it was page 78 and 79, if I remember correctly. So on A, it's multiplying by 1 and it's still equal to 7. So what is that called? I think that was on page 78. Identity property of multiplication. No. That left page is not as important as the right page. You do need like the addition property of equality and the multiplication property of equality and transitive property and substitution. Some of them were important. A lot of them were not important. B, what's it when 6 plus 9 equals 9 plus 6? What was that called? No.
Reflexive? No.
That kind of is like the symmetric property, isn't it? But that's not what they put. It's the one about, like, it doesn't matter which order you add things in. No. It's on page 78. Commutative property of addition. The symmetrical property was, there was no plus in it. It was just like this. If A equals B, B equals A. Alright, which one does C look like? Basically it's, yeah, associative property of multiplication. Doesn't matter what order you multiply a bunch of factors in. Associative property of multiplication. These are on page 78. D basically says when you add opposites together, they add up to 0.
Inverse.
Inverse property of addition. Alright.
So we don't need any of these on this list.
Not those four, no.
Then why do we do that?
Well, it's more, we did that assignment as a practice for like giving a reason for proof lines, but those four don't really translate to geometry. But remember how in the proofs we did like addition property of equality and we did we did substitution. Some of those do translate to geometry pretty well. It's kind of, it was practice for giving reasons for proof lines, basically. Okay, 39. This assignment was probably about a week ago. What it says, name the definition, postulate, or property that is happening here. So if segment CD is congruent to segment GH, then what's the difference between these two?
One's congruent, one isn't.
This is talking about the segments themselves being the same, and this is talking about the length of the segments being equal. You guys remember what this one was?
Congruent something.
Yes. If the segments are congruent, their lengths are equal. That is the definition of congruent segments. Oh, this one wasn't on page 78 and 79. This was the next assignment over. Um, 38 was on page 12. 12, I'm pretty sure it was all those postulates. Probably recognize 40. 41, which three properties, oh, yeah, I don't really like this. Must be true in any equivalence relation. I don't really like this question. We'll skip it. I'm not even gonna write it down. You're talking about page 79, basically. Reflexive, symmetric, transitive, the equals stuff. Okay, 43. Here's a little bit of, for you algebra people. Okay, what do we know about those two angles on 43? They're equal, they're congruent to each other. So the left one equals the right one, right? They're not trying to trick you here. There's not supposed to be a trick question on this one. 4x plus 9 equals 6x minus 7. Then what do I do? We got x's on both sides, right? So get rid of the x's on one side. Oops. Guess. B says, what's the measure of angle GKJ?
41.
6 times, yeah, plug 8 in. 6 times 8 minus 7. 41 degrees.
And then you do like 41 and then minus 180 minus 41.
Yeah, if you, on C, if you look at angle FKG in the picture, which angle is that?
That's top one.
Top one. And what do we know about the top angle and this angle right here? They make 180. They make a straight line. They remember what the book called them? Linear pair. Always adds up to 180. That's linear pair theorem. So yeah, this one was 41. So what do we need to do? 180 minus 41 is
139.
and 44. That's a linear pair also, right? So you have to set up that equation a little bit differently than 43. All right. 45. All right, these questions aren't hard, but if you don't draw a picture, it'll probably confuse you. So I highly recommend you try to draw a picture and see what they're talking about. 45, M is the midpoint of XY, so draw segment XY. So draw a segment XY, put M in the middle, and then what? It says XM equals 39. What does that mean? It means,
The distance between x and m is 39.
exactly, yes. So what do I know if that's true?
The distance between m and y
This
is 39.
my is 39. Now let's see what the question is. Find XY.
39 times 2.
39 times 2 is
78.
so people will see all those letters and like panic because they don't know what's going on. So that's why the picture is very helpful. Once you see it in the picture, it gets really easy. 46 pretty much the same. Similar. Yeah, I'll let you guys try it. 47, right, an algebraic proof. How far did I say we're going?
54.
Yeah, I do want to do 47, and I don't know if I'll do all this, though. We might not have time.
We should just go for something.
We'll see. No, I do want to do most of those. I'm not sure if I want to do all three of these proofs, though. 47. Okay. So we're writing it from scratch by ourselves, right? So we need statement and reason. You guys know what the first statement's going to be? And what's given on 47? Reason given. And we're done when we get to x equals -8, right? Like basically solving it, but doing it in proof form instead of like what we did last year. Actually there's two ways we could do, maybe you guys don't know that. Did you know there's two ways to solve this problem? What's one way we could distribute? Does anybody know the other way? It says distribute. Since this whole left side is multiplied by 2, you could get rid of the 2 by dividing by 2.
So it's just distribute.
Fine.
I don't want to get confused.
If you just divide by 2 on the left, the 2 just disappears. But, because it's the opposite of times 2.
So it'd be x plus 5 equals -3.
Yeah. But if you do it that way, Jarrett, you're going to have to write your own. Because, yeah, I wanted to. So what's the reason over here?
Distributive property.
Yeah, we use distributive property.
You're gonna have to write out this on the test.
I'm going to make a proof, yes. I don't know. I probably won't do an algebra proof, though. They did the algebra proof because you guys are familiar with this as like a warm-up to the geometry proofs.
Is it gonna be like, right now, there's one missing, or do we have to write it all?
I think, I don't remember, but I think I might have put a blank short proof. But we'll talk about it the day before to make sure you guys get how it works. I'll just, anyway. Now what, if we were solving this, what would we do?
Subtract 10.
Subtract 10. What's it called if you subtract the same value on both sides? It's kind of a trick question. Remember? I just forgot last week. Addition, property of equality. Why is it called addition if we are subtracting 10 on both sides?
Subtraction doesn't matter.
Because subtracting is just adding a negative, basically. So instead of calling it subtraction property, they just decided to call it addition property again. If you actually put subtraction property of equality on the test, I would probably give you credit, because that's close enough. Some books do call it subtraction property. Whatever. Alright, now what would we do to solve? Divide by 2. But it's not called division property of equality, it's called multiplication. Dividing by 2 is like multiplying by 1/2.
Do you want us to do those other things?
No. So I'll just say skip 48 and 49. I wanna start doing the geometry proofs instead. Okay, so 50 through 53 is basically like a couple lines from a proof, and we're supposed to fill in the blank. So on 51, the first line is blank. The second line says angle R is congruent to angle S because all right angles are congruent. So what must we have known on line 1?
Angle R was equal to angle S.
No.
Wait, that says congruent on two.
Yeah, on line 2 it says angle R is congruent to angle S, and the reason they gave was because all right angles are congruent. So what must we have known right before that? They're both 90 degrees, I would accept that, or they're both right angles. So if you put, yeah, they're 90 degrees, that's fine. I'm just gonna put angle R and angle S are right angles. It's kind of a duh statement, but sometimes proofs can, if they're being very exact, sometimes they do a duh statement. Obviously, if they're both right angles, they are congruent. I probably wouldn't point that out in a proof, because it's just a little bit tedious. All right, 53, they give us the first line. Segment AB bisects segment CD at point P. Then what do we know? Segment CD bisects segment, no, AB, said it backwards. AB bisects segment CD at point P. What do we know by definition of segment bisector? Well, you guys remember what bisect meant? We went over this definition, but we didn't really. Cuts it into two equal pieces. So if you put CP equals PD, I would accept that. But what they put is that P is the midpoint of CD. A segment bisector always goes through the midpoint because it's cut in half. So P is the midpoint of CD. So a segment bisector and a midpoint are very closely related. The segment bisector goes through the midpoint, and the midpoint splits the segment into two equal pieces. So, yeah. All right. Oh, 54 is the last one. Okay, here we go. Actually, I want you guys, let's see how much time we have. 2, 5, 3. We got a lot. We got like 17 minutes. I want to give you guys like 3 minutes and see how far you can get on this proof by yourselves. See what you can figure out. It's okay if you get something wrong. Just, I definitely expect everybody to get the first line. See what else you can figure out.
What do you mean?
Which one?
54.
You try to do
It's a make your own proof. Oh, no, it's not. They filled in the blank. Dang it. Thought it was make your own.
Just filling in all the reasons.
Yeah, why don't you go ahead and try, fill in the reasons. Why don't you guys go ahead and try 54 though. And I thought it was a bullet, I didn't see those lines down there. Hmm, yeah.
What's adjacent mean again?
Use a share side. Where are you looking at?
50.
Maybe stumped on 55. Alright, line 2, why do we know angle 1 is congruent to angle 4 and angle 5 is congruent to angle 7? Really? Nobody knew?
What is it? Sorry.
Huh? No. How do we know that angle 1 is congruent to angle 4? Vertical angles, good. Technically that is a theorem, but if you put vertical angles, that's good enough for me.
Theorem, not a definition.
It's not a definition. Definition is that 1 and 4 are vertical angles, but not that they are congruent. But if you just put vertical angles, that's fine.
That's what I said, number 3.
Yeah. Okay, somebody besides Jarrett. Natalie probably heard him. So maybe not Natalie either. How do we know that 1 and 7 are the same?
They're congruent. Right?
Well, that's what congruent means, but how do we know that?
They're.
It has something to do with lines 1 and 2.
They add up to 180?
No?
No.
Okay, line 1 is that 4 and 5 are the same, right? Line 2 is that 1 is the same as 4 and 5 is the same as 7. So 1's the same as 4, 4 is the same as 5, 5 is the same as 7. So how do
So
we...
it's the transitive thing.
Transitive property. It's the longer train than normal, but it is the transitive property.
What is supplementary?
Supplementary angles add up to 180. And if they know those two angles add up to 180 on the second line, that's because they must have known it.
Yeah.
or something. yourself before you ask for help.
Yeah, probably.
You could have used your crutches and like grabbed it. There you go. Now you don't have to ask for help. Still got a dirty Kleenex though.